Let's look at converting standard form, which you see here, into vertex form, which is really useful to find the vertex of the parabola. So sometimes we want to start with the standard form, but convert it to vertex form to just make our life easier to know where the vertex is. So we are going to use a completing the square process. So the first thing we do is we make a little bit of space for that constant. So we make a little bit of space right there. Now we're going to complete the square just like you did when you learned how to complete the square. And if you need a little help on that, I'll link to the video I have on completing the square. But you take that middle term, that negative 2x, and you divide the negative 2 in half. And you write it down here in the perfect square. Now, if you were to FOIL that out, what did we just insert? Remember, negative 1 times negative 1 is actually negative 1 squared, which is a positive 1. So in order to complete the square on that x squared minus 2x plus something, we'd have to have a plus 1 there. Now you can't just put a plus 1 on the right side of an equation without doing the same on the other side, right? So we could put plus 1 on the other side, but here we're going to put a negative 1 to just balance it out, because 1 plus negative 1 is 0, of course, so they cancel each other. So now we combine the like terms of the 5 and the negative 1, and we get a positive 4. So vertex form is y equals the quantity, x minus 1, that quantity squared, plus 4. So that means the vertex is at 1, 4. The vertex is at 1, 4. Let's try another one. Here we have x squared plus 6x plus 10. That's our function. So remember, the first thing we do is make a little bit of space so that we can complete the square. Move that 10 out of the way. And we're going to complete the square by dividing the positive 6 in half. And that goes down here. So this is x plus 3, the quantity squared. Now, by creating that square, we have, in essence, put a 3 squared right here, right? That's 9. So how do we counteract that? We balance it out with a negative 9 or a negative 3 squared. So we have 10 minus 9 is 1. It's simple as that. That's how you convert from standard form to vertex form. Now I do have one more twist on the next example. So what's different here is that we have that minus sign out front on that x squared. The leading coefficient is a negative. So I imagine there's a couple different ways to do this, and I've thought about it, and this is the way I'm going to approach it here. We're going to factor that minus 1 out right from the beginning, but I'm going to only do it on the first 2 terms, and I'm going to leave a little bit of space right there, and then that minus 2 is still just over there with the minus 2. Now let's complete the square on that middle part, the x squared minus 6x, and then what would it be? Well, just like that last problem, we're going to divide the negative 6 in half. That's 3. So we get x minus 3, the quantity squared, which means we have a plus 9 right here, right? Because negative 3 squared is positive 9. Now don't forget about this minus sign right here that applies to that positive 9. So by putting that positive 9 there, I really put negative 9 on that right side of the equation. So I have to balance it with a positive 9 over here. See, the positive 9 balances that negative 9 that's actually on the left part of the problem. So we have plus 7. So y equals the quantity, and I need to put the minus sign in the front. That's still there, of course. Minus 1 times the quantity, x minus 3, the quantity squared, plus 7. So the vertex here would be at 3, 7. And this parabola opens down. So it would be concave down like a frown because that leading coefficient is negative. So that's one way to approach how to convert standard form with that leading coefficient not equal to 1. Go ahead and just factor it out. That's how you could convert it into vertex form. Okay, good luck, and don't forget to subscribe to this channel and like this video so you have quick access to all my videos. All right, until next time.